Somewhere out there, beyond the thin blue veil of our atmosphere, beyond the moon, beyond the reach of every rocket humanity has ever built, the universe stretches for 93 billion light-years in every direction. It is ancient, vast, and almost entirely unknown. And somewhere in that immensity, in a galaxy we cannot name, on a world we cannot see, under a sky we cannot imagine, there may be something looking back at us. That question has haunted human beings for as long as we have had the capacity to look up. Before science, we answered it with myths and gods and spirits. Then came telescopes, then radio receivers, then space probes carrying golden records with the sounds of Earth, launched into the dark like messages in a bottle, thrown into an ocean with no shore. And still we do not know the answer. Are we alone? What makes this question different from every other mystery humanity has ever pursued is its weight. If the answer is yes, if we are alone, then this entire universe, in all its incomprehensible scale, exists for exactly one species on exactly one small rock circling an ordinary star in the outer arm of a middle-sized galaxy. The loneliness of that thought is difficult to fully absorb. But if the answer is no, if there are others, then everything changes. Every assumption we have ever made about our place in creation, about our uniqueness, about our importance, becomes something that has to be reconsidered from the beginning. Think about what it would mean to receive confirmation, any confirmation at all, that life exists beyond our world. Even a single-celled organism found in a Martian rock sample, or a chemical signature in the atmosphere of a planet 40 light-years away, would instantly and permanently alter our understanding of biology, of chemistry, of our own origins, and of the deep structure of the universe. The implications would ripple through every field of human knowledge. Philosophy, religion, politics, economics, the arts. Nothing would be exempt from the revision that would follow. It would be the greatest discovery in human history, by a margin that no other discovery comes close to matching. We are going to spend the next 2 hours exploring everything we currently know, everything we suspect, and everything we cannot yet explain about life beyond Earth. We will travel to the edge of the habitable zone, examine signals that have never been fully explained, look at photographs that scientists argue about even today, and listen to the testimony of people who have seen things in the sky that do not fit into any known category. This is not a story with a clean ending. The mystery is still open. But the evidence, the real, documented, peer-reviewed, declassified evidence, is far stranger and far more compelling than most people realize. Let us begin where all life as we know it begins, with the right conditions. When astronomers talk about the possibility of life on other worlds, they almost always start with something called the habitable zone. The concept is straightforward enough. Every star in the universe radiates heat and light. If a planet orbits too close to its star, temperatures become too extreme for liquid water to exist on the surface. The water boils away into the atmosphere and is eventually lost to space. If it orbits too far away, water freezes solid and surface oceans become impossible. But in between, in a band of space sometimes called the Goldilocks zone, conditions are just right. Temperatures can allow liquid water to persist on a planetary surface, and liquid water, as far as we know, is the single most essential ingredient for life. Earth sits comfortably inside the Sun's habitable zone. We are approximately 93 million miles from the Sun, a distance that gives us seasons, weather, oceans, and the possibility of complex biology. We are not exactly in the center of the habitable zone. Venus is closer to the center, in fact. But Earth has other advantages that Venus lacks, including plate tectonics, a large moon that stabilizes our axial tilt, and a planetary magnetic field that protects the surface from solar radiation. It is worth noting that the habitable zone is not a fixed rule, but a range of probabilities. Some planets slightly outside the classical definition might still harbor life if they have thick atmospheres that trap heat, or if they receive tidal heating from gravitational interactions with nearby moons or companion planets. Conversely, a planet within the classical habitable zone might still be sterile if it lacks the right chemical composition, geological activity, or protective magnetic field. The zone is a starting point, not a guarantee, but it is one of the most powerful tools astronomers have for narrowing down candidates in the vast catalogue of known worlds. For most of human history, we had no way to know whether other stars had planets at all. The distances involved are so enormous that even the most powerful telescopes available until relatively recently could not directly image a planet around another star. They were simply too small and too dim compared to the blazing light of their host stars. It was like trying to spot a firefly sitting next to a searchlight from 10 miles away. That changed in 1992, when astronomers detected the first confirmed exoplanets, planets orbiting a star other than our Sun. The discovery was not quite what anyone expected. The star was a pulsar, the collapsed remnant of a dead star that emits regular pulses of radio energy. The planets orbiting it had survived the star's supernova explosion, which is itself a remarkable testament to the tenacity of planetary systems. They were not promising candidates for life, but their detection proved that planetary systems were not unique to our Sun, and it proved that planets could form and survive in environments far more hostile than our own. Then, in 1995, astronomers Michel Mayor and Didier Queloz announced the discovery of a planet orbiting a Sun-like star, 51 Pegasi, about 50 light-years from Earth. The planet, designated 51 Pegasi b, was a gas giant about half the mass of Jupiter, orbiting its star in just 4 days. It was far too close to its star for life, but its existence proved something crucial. Planets form around Sun-like stars. The universe makes them routinely. The method used to detect it, the radial velocity method, which measures tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet, became one of the primary tools in the exoplanet hunters kit. Mayor and Queloz eventually received the Nobel Prize in Physics for this work in 2019, more than 2 decades after their discovery. That long delay says something about how slowly the scientific establishment came to appreciate the magnitude of what they had found. From there, the floodgates opened. Ground-based telescopes began finding more exoplanets, mostly large gas giants, because they were the easiest to detect. They produce larger wobbles in their host stars and block more light when they transit. But the real revolution came in 2009, when NASA launched the Kepler Space Telescope. Kepler's mission was simple in concept and breathtaking in execution. It stared at a patch of sky containing roughly 150,000 stars simultaneously and watched for the tiny, periodic dimming that occurs when a planet passes in front of its star, what astronomers call a transit. The dimming is extraordinarily small. When Earth transits the Sun, it blocks about 0.01% of the Sun's light. Kepler was sensitive enough to detect that. It was, in essence, an eye of almost superhuman precision, staring without blinking at a vast field of stars, waiting for the shadow of a world. Over 9 years of operation, Kepler confirmed the existence of more than 2,600 exoplanets and identified thousands more candidates awaiting confirmation. The results were staggering and world-changing in their implications. Planets are everywhere. They orbit almost every type of star. Some stars have multiple planets. Some planets are rocky, like Earth and Mars. Some are ocean worlds, covered entirely by liquid. Some are super-Earths, rocky planets significantly larger than our own, with no analog in our solar system. Some are mini-Neptunes, and many of them, far more than anyone had dared to predict, orbit within the habitable zones of their stars. Kepler's most important statistical finding was this: the Milky Way galaxy alone probably contains tens of billions of Earth-sized planets in the habitable zones of their stars. Tens of billions. When you hold that number in your mind and remember that the Milky Way is just one of perhaps 2 trillion galaxies in the observable universe, the idea that ours is the only world that ever developed life starts to strain credulity almost beyond its breaking point. The universe has not just provided the conditions for life to arise in one place. It has replicated those conditions on a scale so vast that the human mind genuinely cannot encompass it. Kepler's successor, the TESS telescope, the Transiting Exoplanet Survey satellite, launched in 2018 and expanded the search to cover nearly the entire sky. Where Kepler stared at one patch for years, TESS scans almost everywhere, particularly focusing on nearby stars whose planets will be easier to study in follow-up observations. TESS has already confirmed hundreds of exoplanets and is expected to identify thousands more. The pipeline of potential worlds never stops filling. Among the most exciting individual exoplanet discoveries of recent years, a handful deserve special attention. The TRAPPIST-1 system, announced in 2017, sent shockwaves through the scientific community. Located just 39 light-years from Earth, close by astronomical standards, TRAPPIST-1 is a small, cool red dwarf star. It hosts 7 known planets, all of them roughly Earth-sized. 3 of them, designated TRAPPIST-1e, F, and G, lie within the habitable zone. They are rocky worlds. They could, in principle, have liquid water on their surfaces. Scientists have since been studying them with the James Webb Space Telescope, looking for signs of atmospheres. The proximity of the system and the number of potentially habitable worlds make it one of the most intensively studied targets in all of exoplanet science. Red dwarf stars like TRAPPIST-1 pose interesting questions for habitability. They are far dimmer than our Sun, so their habitable zones are much closer in. A planet in the habitable zone of a red dwarf is likely tidally locked. One hemisphere permanently facing the star, perpetually day. The other permanently turned away, perpetually night. For a long time, it was thought that such conditions would make a planet uninhabitable, a scorching dayside and a frozen nightside. But climate models have shown that if the planet has an atmosphere, winds can redistribute heat between the hemispheres, potentially creating habitable zones around the terminator, the line between eternal day and eternal night. Life, if it exists on such worlds, would be adapted to environments unlike anything on Earth. But adaptation, as life on our own planet has repeatedly demonstrated, is what life does. Then there is Proxima Centauri b. Proxima Centauri is the closest star to our Sun, just 4.2 light-years away. A distance that remains impossible for current spacecraft, but which, if propulsion technology ever advances sufficiently, would be reachable within a human lifetime. In 2016, astronomers confirmed a planet orbiting within its habitable zone. The planet is thought to be roughly Earth-sized. Whether it has an atmosphere, liquid water, or any form of life is entirely unknown. There are concerns that Proxima Centauri, like most red dwarfs, is far more active than our Sun, producing frequent and intense stellar flares that might strip away an atmosphere over time. But those concerns, while serious, are not definitive. Some researchers have proposed that an atmosphere could be maintained against flare erosion if the planet has a strong enough magnetic field. The argument continues. What would it take for a planet to actually support life? Astronomers have developed a list of factors that seem important. Liquid water is first, but it is far from the only consideration. A planet needs a source of energy, most likely from its star, though internal geological heat can also work, as we will discuss shortly. It needs chemical building blocks: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These 6 elements are the primary ingredients of biochemistry as we know it, and they are among the most abundant elements in the universe. They are found throughout the galaxy, in stars, in interstellar gas clouds, in comets and asteroids, and in the atmospheres of many known exoplanets. A habitable planet also needs some degree of geological activity to cycle nutrients and maintain atmospheric composition over billions of years. On Earth, plate tectonics plays a crucial role in the carbon cycle, drawing carbon dioxide out of the atmosphere into rock and returning it through volcanoes, regulating temperature over geological timescales. A planet without active geology might gradually lose its atmospheric balance and become permanently frozen or permanently roasting. It also ideally needs some form of protection from its star's most energetic radiation, which on Earth is provided by our magnetic field and ozone layer. Without these shields, ultraviolet radiation and charged particles from stellar winds would break apart complex molecules on the surface and inhibit the development of life. Not every planet will have all of these. But the universe has had 13 billion years to experiment, and it has done so around hundreds of billions of stars, each of which may host multiple worlds. The question is not whether life could arise somewhere else. The question, for many scientists, is simply where and what it looks like. Before we discuss the search for intelligent civilizations, we must not overlook the possibility of simpler life, microbial life, single-celled organisms, the microscopic chemistry of survival that dominated Earth for billions of years before anything with eyes or ears evolved. Complex life on Earth is relatively recent. The first cells appeared approximately 3.5 to 3.8 billion years ago. The first complex multicellular organisms appeared only about 600 million years ago. For more than 3 billion years, the most sophisticated thing on this planet was a bacterium. And for those 3 billion years, microbial life transformed this planet completely, building up the oxygen atmosphere, changing the chemistry of the oceans and rocks, creating the conditions that eventually made complex life possible. Microbial life, if it exists elsewhere, may be both more likely and more important than any Hollywood version of alien contact. Finding a fossil microbe in a Martian rock would not be as dramatic as finding a spacecraft, but it would be infinitely more scientifically significant. It would tell us that life arose independently in 2 places in the solar system, which would have enormous statistical implications for how common life is throughout the universe. For the possibility of microbial life, we do not need to look as far as TRAPPIST-1 or Proxima Centauri. We need only look at 2 worlds within our own solar system. Mars is the obvious candidate. It is close. It is rocky. It has been extensively studied, and every mission we have sent there has confirmed something remarkable. Mars was once a very different world. Billions of years ago, liquid water flowed across its surface. Rivers cut channels into the rock. Oceans may have covered portions of the northern hemisphere to depths of 1 kilometer or more. The atmosphere was thicker, warmer, and possibly rich enough in greenhouse gases to sustain liquid water at the surface for extended periods. For perhaps hundreds of millions of years, ancient Mars had conditions that were at least superficially similar to early Earth, the same early Earth on which life first appeared. Today, Mars is cold, dry, and barren on its surface. Its atmosphere is thin, less than 1% of Earth's pressure, and mostly carbon dioxide. Ultraviolet radiation from the sun bombards the surface without mercy because Mars lost its global magnetic field billions of years ago, likely when its liquid iron core solidified. Surface water is unstable, instantly boiling and freezing in the tenuous atmosphere. Any organic molecules at the surface are rapidly broken apart by the ultraviolet radiation and by powerful oxidizing chemicals produced in the soil by that same radiation. But underground is a different story. Beneath the surface, protected from radiation, possibly warmed by geothermal heat, liquid water might still exist. In 2018, researchers announced radar evidence from the MARSIS instrument aboard the Mars Express spacecraft for a subglacial lake beneath the south polar ice cap of Mars, approximately 20 kilometers across and potentially several meters deep. The discovery was controversial. Subsequent analysis suggested the radar signal might alternatively be produced by certain clay minerals rather than liquid water. But the possibility of subsurface liquid water on Mars has not been ruled out, and subsequent radar studies have suggested additional anomalies in the same region. More tantalizing still is Europa, one of Jupiter's 4 large moons. Europa is covered by a smooth shell of ice, cracked into a complex network of ridges and bands that suggests a dynamic subsurface. Beneath that ice, evidence strongly suggests a global ocean of liquid water. The ocean exists because Jupiter's immense gravity flexes Europa as it orbits, in competition with gravitational tugs from the other large moons. This flexing generates friction and heat, a process called tidal heating, that keeps water liquid even though Europa is far beyond the Sun's habitable zone in the classical sense. Europa's ocean may be more than 100 kilometers deep. It may have hydrothermal vents on its floor, similar to the deep-sea vents on Earth, where entire ecosystems thrive without any sunlight at all, powered instead by chemical energy from the interaction of hot rock and seawater. NASA is preparing the Europa Clipper mission to study this moon in detail. Whether anything lives in that dark, hidden ocean is one of the most profound open questions in science. Enceladus, a moon of Saturn, also has a subsurface ocean. It is actively venting material into space through enormous geysers at its south pole, spraying a plume of water vapor and ice particles high above the surface and into Saturn's ring system. The Cassini spacecraft flew through those plumes multiple times and detected water ice, salts, silica, and organic molecules, including complex organic compounds heavier than any previously found in the outer solar system. Scientists also found molecular hydrogen in the plumes, which is produced when hot rock reacts with water. Exactly the kind of chemical reaction, called serpentinization, that supports entire biological communities near hydrothermal vents on Earth. Enceladus is small, just 500 kilometers across, but it may be one of the most promising places in the solar system to look for microbial life.
And it is conveniently venting its ocean directly into space, where future spacecraft could sample it without even needing to land. There is also Titan, another moon of Saturn, and perhaps the most alien world in our solar system. Titan has a thick atmosphere, thicker than Earth's, with a surface pressure 50% higher, composed mostly of nitrogen, with complex organic chemistry unlike anything else we know of. Its surface has lakes and rivers, not of water, but of liquid methane and ethane. Its clouds rain liquid hydrocarbons onto a landscape sculpted by the same processes as Earth, rivers, deltas, dunes, but using radically different chemistry. Life on Titan, if it exists, would be radically different from anything we know. It would not use water as a solvent. It would not breathe oxygen. It would be alien in the most complete sense of the word. But the chemistry is there. The organic building blocks are there, in abundances that dwarf anything found on Mars. The question of whether chemistry, given enough time and the right conditions, inevitably organizes itself into biology is one that Titan might help us answer. The atmosphere of Venus, counterintuitively, has also been proposed as a possible home for microbial life. The surface of Venus is hellish. Temperatures above 460 degrees Celsius. Atmospheric pressure 90 times that of Earth. Clouds of sulfuric acid so thick that spacecraft sent to the surface have survived for only minutes before being crushed and dissolved. Nothing we know of could survive there. But in the cloud layers above the surface, at altitudes between 48 and 60 kilometers, temperatures and pressures become more moderate, roughly comparable to conditions in Earth's upper atmosphere. The droplets of sulfuric acid in those clouds contain traces of water. In 2020, a team of researchers announced the detection of phosphine gas in Venus's atmosphere. Phosphine is produced on Earth almost exclusively by biological processes or by industrial synthesis. It forms when microorganisms break down organic matter in low-oxygen environments. The announcement was controversial, and subsequent reanalysis suggested the signal might have been weaker than initially reported, or might have an alternative explanation involving unusual atmospheric chemistry. The debate is unresolved, but it opened a serious scientific discussion about whether life might exist in the clouds of Venus, drifting in permanent atmospheric rivers, living entirely airborne in acid droplets, absorbing ultraviolet light the way plants absorb visible light on Earth. All of this, the habitable zones, the exoplanets, the ocean moons, the atmospheric signatures, the chemical fingerprints, is the scientific backdrop against which everything else we are about to discuss must be understood. Life, as far as we can tell, wants to exist. It appears in environments on Earth that were thought to be completely inhospitable until we looked closely. Thermophiles thrive in boiling acidic pools in Yellowstone. Halophiles live in hypersaline lakes where nothing else survives. Psychrophiles reproduce in Antarctic ice at temperatures below freezing. Radiotrophic fungi grow on the walls of the damaged Chernobyl reactor, feeding on ionizing radiation. Organisms have been found in the deepest points of the ocean, in the stratosphere, in the deep crust of the Earth, in highly alkaline lakes, in intensely irradiated environments. Life is opportunistic, adaptable, and extraordinarily persistent. The universe is old, vast, and full of the raw materials life needs. The probability that ours is the only instance of it seems, to put it charitably, profoundly improbable. Now we turn to a different category of evidence, not the theoretical and the probabilistic, but the observed and the documented. And here, the story becomes considerably stranger. the modern history of unidentified aerial phenomena begins. Officially, on June 24, 1947, pilot Kenneth Arnold was flying his small plane near Mount Rainier, Washington State, when he observed 9 unusual objects flying in formation at high speed. He described their motion as similar to saucers skipping across water. A journalist misunderstood the description and reported them as saucer-shaped objects, and the term flying saucer entered the cultural vocabulary of the 20th century. Arnold's account was not the first of its kind. Similar objects had been reported by pilots during World War II, where they were called Foo Fighters, but it was the report that catalyzed public and government attention. For the next several decades, UFO sightings were treated primarily as a social phenomenon, the product of Cold War anxieties, overactive imaginations, and the occasional misidentification of aircraft, weather balloons, the planet Venus, or other celestial objects. The United States government ran official investigations, most notably Project Blue Book, which operated from 1952 to 1969 and examined over 12,000 reports. The official conclusion was that the vast majority of sightings had conventional explanations, and that no evidence suggested any of them represented extraterrestrial craft. The program was headed at various points by military officers and scientists, including the physicist J. Allen Hynek, who was initially a committed skeptic and eventually became one of the most prominent voices arguing that the phenomenon deserved far more serious investigation than it was receiving. But Project Blue Book had a problem it never fully addressed. It left approximately 701 cases categorized as unidentified. These were not the misidentifications. They were the reports that could not be explained by any known phenomena, even after thorough investigation. And critics of the project, including several of the scientists and military officers involved in it, argued that the investigation was not conducted in good faith, that the conclusion was decided in advance, and that inconvenient cases were quietly pushed aside. Hynek himself, years after the program's closure, stated that the Air Force had deliberately downplayed and suppressed significant cases because acknowledging them would have been uncomfortable. The attitude of governments toward unidentified aerial phenomena changed dramatically in December 2017, when the New York Times published an investigation revealing the existence of the Advanced Aerospace Threat Identification Program, or AAT, secret Pentagon program that had operated from 2007 to 2012 with a budget of $22 million. The program was initiated largely through the efforts of Senator Harry Reid of Nevada, who had been persuaded by businessman Robert Bigelow that the phenomenon was real and worth serious government attention. The program was run by a career intelligence officer named Luis Elizondo, who later resigned from the Department of Defense, citing frustration with what he described as excessive secrecy and obstruction around the subject. Along with the article, the Times released 2 declassified videos filmed by U.S. Navy fighter pilots. One, later nicknamed the Tic Tac video, showed a white oblong object moving erratically over the Pacific Ocean near San Diego in November 2004. The object displayed flight characteristics that defied conventional explanation. It appeared to accelerate and decelerate instantaneously, made sharp turns without any visible means of propulsion, and dropped from an altitude of 80,000 feet to near sea level in seconds, a maneuver that would require acceleration many times beyond what any known aircraft can withstand, and far beyond what any human pilot could survive. It had been tracked by the radar systems of the USS Princeton for several days before the pilots were sent to investigate, and the radar operators described it as behaving unlike anything they had ever seen in decades of service. The pilots who encountered this object, Commander David Fravor and Lieutenant Commander Jim Slate, were experienced naval aviators with thousands of flight hours between them. Fravor has spoken publicly about the encounter many times. He described the object as unlike anything he had ever seen in his career. It had no wings, no visible propulsion system, and no exhaust. It seemed to be aware of his presence, mirroring his movements initially before accelerating away at a speed he could not track. He said he did not know what it was, but that it was clearly controlled by some intelligence. Fravor was not a man given to dramatic interpretation. His account was measured, precise, and consistent across every telling. A second video, released at the same time, later called Gimbal, showed an object moving at high speed and rotating as it moved. The rotation was not a tumbling motion of the kind you might expect from an object spinning in free flight. It appeared systematic, deliberate. A third video, later released separately by the Pentagon and called GFOST, showed another object moving at extraordinary speed just above the ocean surface, so low that the radar tracking it could not distinguish it from the ocean's surface clutter, with Navy pilots expressing audible astonishment on the audio track. The object appeared to be moving at hundreds of miles per hour without any visible propulsion, exhaust, or aerodynamic surfaces. In 2020, the Pentagon officially acknowledged these videos, stating that they were authentic recordings made by U.S. Navy personnel and that the objects in them had not been identified. This was not a statement made by a tabloid or a conspiracy website. This was the United States Department of Defense, acknowledging on the record that its own military pilots had encountered objects that exhibited capabilities beyond known human technology, and that the department could not explain. The following year, the government went further. In June 2021, the Office of the Director of National Intelligence released a report titled Preliminary Assessment, Unidentified Aerial Phenomena. The report examined 144 reports of UAP encounters by military personnel between 2004 and 2021. Of those, it was able to explain only one, a large deflating balloon. The remaining 143 remained unidentified. The report noted that UAPs clearly pose a safety of flight issue and may pose a challenge to U.S. national security. Also noted that the government's ability to collect and analyze data was hampered by fragmented reporting systems, stigma around reporting, and the lack of dedicated sensors and analysis infrastructure. It was a tacit admission that the government had not been taking the phenomenon as seriously as it warranted. In 2022, Congress held the first public UAP hearing in more than 50 years. Deputy Director of Naval Intelligence Scott Bray testified before the House Intelligence Committee alongside Undersecretary of Defense for Intelligence and Security Ronald Moulton. Bray stated that the number of UAP reports in the military had grown significantly in recent years, partly because official policy changes had reduced the stigma around reporting such incidents. He confirmed that the objects in the Tic Tac video had never been explained. He also showed a new piece of footage, a spherical, metallic-looking object flying past a Navy aircraft at high speed. It was on screen for less than 2 seconds, but it was clearly not a weather balloon, a drone, or any known conventional aircraft. When a committee member asked directly whether the government had found any evidence of extraterrestrial origin for any U.S., Bray answered no, but added that the question remained open and that the government lacked the data to rule it out. These are not the accounts of fringe figures. These are career military officers, intelligence professionals, and senior government officials speaking under oath before Congress. Their testimony does not prove that unidentified aerial phenomena are extraterrestrial in origin. What it proves is that something real has been observed repeatedly by trained observers with sophisticated instruments, that it exhibits capabilities beyond known human technology, and that the most powerful military in the world does not know what it is. The Navy encounters are far from isolated. Across decades and across every continent, pilots, commercial and military, have reported encounters with objects that behave in ways inconsistent with known aircraft. The common characteristics reported across thousands of independent accounts include instantaneous acceleration without any sonic boom, the ability to operate in air, on the surface of the water, and apparently underwater without apparent transition or loss of performance, no visible propulsion system, controlled surfaces, or exhaust, behavior that seems to suggest awareness of surrounding aircraft, and in many cases, the simultaneous appearance of multiple objects. The Nimitz encounter of 2004, which produced the TikToky video, was accompanied by radar data suggesting that the same or similar objects had been operating in the area for weeks before the pilots investigated. The objects appeared to move from altitudes of 80,000 feet to the surface of the ocean in less than a second, then returned to altitude, repeatedly, during the days that the Princeton's radar was tracking them. The pilots sent to investigate on November 14th were not the first to be dispatched. Previous attempts to intercept had resulted in the objects departing before visual contact could be made. What is perhaps most striking about the pattern of military UAP encounters is not any single incident, but the consistency of the described characteristics across time, across geography, and across the testimony of people who had no contact with each other and nothing to gain from fabrication. Pilots risked their careers and reputations by reporting such incidents. Many have said so explicitly that they waited years to speak publicly because they feared professional consequences, because they knew that reporting such things was culturally associated with instability or the ones who have chosen to speak tend to be the most experienced, the most credentialed, and among the most cautious in their interpretations. They do not claim to know what they saw. They claim only that they saw something real, something extraordinary, and something that does not fit into any category of known human technology. We will return to the question of what these objects might be. First, we must go even deeper into the mystery, not into the skies of Earth, but into the electromagnetic spectrum of deep space, where signals have arrived that have never been fully explained. Radio astronomy was born in the early 1930s when a Bell Labs engineer named Carl Jansky accidentally discovered that the Milky Way emits radio waves while trying to identify the source of interference in transatlantic telephone transmissions. The universe, it turned out, is not silent. Stars, gas clouds, pulsars, black holes, galaxies, all of them produce radio emissions across a vast range of frequencies. Astronomer Grote Reber built the first purpose-built radio telescope in his backyard in Wheaton, Illinois in 1937, and mapped the radio sky by hand. Learning to read this cosmic radio landscape has since become one of the most powerful tools in the astronomer's toolkit. But almost from the beginning, radio astronomers asked the question: if intelligent beings elsewhere in the galaxy wanted to communicate across interstellar distances, radio waves would be a logical choice. They travel at the speed of light. They pass through the interstellar medium with relatively little distortion. They can carry information efficiently, and the technology required to generate and detect them is relatively straightforward, sufficiently advanced, perhaps, but not impossibly so. In 1959, physicists Giuseppe Cocconi and Philip Morrison published a paper in the journal Nature, arguing that the frequency of 1420 megahertz, the frequency at which neutral hydrogen emits radiation, and thus a frequency that any technically sophisticated civilization familiar with atomic physics would know was the most logical channel on which to broadcast or to listen for signals of extraterrestrial intelligent origin. The following year, Frank Drake pointed a radio telescope at two nearby sun-like stars, Tau Ceti and Eridani, and listened for 73 days. He heard nothing remarkable, though there was a brief, excited moment early in the project when a strong, unusual signal was detected. That turned out to be a classified military aircraft. But the framework he helped establish the search for extraterrestrial intelligence, or SETI, has guided decades of subsequent work and inspired the imaginations of generations of scientists. Then came August 10th, 1977. Astronomer Jerry Emmon was working as a volunteer at the Big Ear Radio Observatory at Ohio State University, which had been conducting a systematic sky survey looking for potential signals of extraterrestrial intelligent origin. Emmon was reviewing the data printouts. In those days, the telescope's output was printed on long sheets of paper when he noticed something extraordinary in the sequence of numbers. The radio telescope scanned across the sky continuously, and for most of the time, the background noise it detected was unremarkable, represented by ones and low numbers in the data. But in this particular passage, the numbers suddenly spiked, climbing 2 letters, the convention used when numbers exceeded 9, reaching a peak of 6. Then, U representing 30, before declining symmetrically back to background. The signal lasted exactly 72 seconds, the maximum duration that Big Ear could observe any point in the sky given Earth's rotation. Its intensity was significantly stronger than normal background noise. Its frequency matched precisely the hydrogen line at 1420 MHz, the exact channel Cocconi and Morrison had identified as the most logical for an interstellar broadcast. Its bandwidth was narrower than any natural radio source known. Its rise and fall over time matched the expected pattern of a point source moving through the telescope's beam as Earth rotated, consistent with a signal. Originating from a fixed point in space, Emmons circled the sequence on the printout and wrote a single word beside it. Wow. The wow signal, as it has been known ever since, has never been explained. It has never been detected again, despite numerous attempts using increasingly powerful telescopes pointed at the same location in the constellation Sagittarius. Proposals have been made that it was produced by a comet's hydrogen cloud, by an intermittent astronomical source, or by some instrumental artifact. But none of these explanations has been confirmed, and the comet hypothesis in particular has been disputed by researchers who have pointed out that comets of the right type were not at the correct position in 1977. The wow signal remains, after nearly half a century, the strongest candidate for a detected signal of extraterrestrial intelligent origin in the entire history of SETI researched. It was heard once and never again, and to this day, no one knows what made it. 40 years after the wow signal, a new class of cosmic phenomena arrived to deepen the mystery. Fast radio bursts, FRBs, are brief, extraordinarily powerful pulses of radio energy that last for just milliseconds. The first one was discovered in 2007 by astronomer Duncan Lorimer in archival data from the Parkes Radio Telescope in Australia. The burst had actually occurred in 2001, and Lorimer initially struggled to understand what he was looking at. In a few thousandths of a second, the source had emitted as much energy as the sun releases in 3 days. The source appeared to be extragalactic, originating from billions of light years away, inferred from the dispersion of the radio frequencies across the pulse, which told astronomers how much material the signal had passed through. That was baffling for 2 reasons. First, to be detectable across such distances, a fast radio burst must be extraordinarily energetic. Second, what natural process could produce such a burst in such a short time? The physics of the mechanism was, and in some respects remains, unclear. In the years since, hundreds of FRBs have been cataloged, and with the commissioning of the Chime telescope in Canada, a cylindrical radio telescope the size of a football field that surveys vast portions of the sky, simultaneously new ones are being detected at a rate of hundreds per year. Most are one-time events, never repeated. But in 2016, astronomers announced the discovery of a repeating FRB, designated FRB 121102, now more formally known as FRB 201-21102A. This one did not fall silent after a single burst. It erupted repeatedly over days and weeks and months from the same location in a dwarf galaxy about 3 billion light-years away. The repetition ruled out any explanation involving a catastrophic one-time event, like a collision or explosion. Something at that location was producing bursts repeatedly, and presumably would continue to do so. The proposed natural explanations for FRBs include highly magnetized neutron stars with magnetic fields trillions of times stronger than Earth's massive black holes, and various exotic astrophysical processes. A magnetar origin was powerfully supported when, in April 2020, an FRB was detected originating from a magnetar within our own galaxy, SIGR 1935+, 2154, providing direct observational evidence for at least one mechanism that can produce these bursts. But this does not rule out other sources, and it does not explain all the properties of observed FRBs, particularly the repeating ones. The universe may produce fast radio bursts through more than one mechanism, just as it produces stellar flares through more than one mechanism. And then there is the question raised openly, if carefully, by some scientists. Could some FRBs be artificial? In 2017, Harvard physicist Avi Loeb and his colleague Manasvi Lingam published a paper in the Astrophysical Journal Letters analyzing whether fast radio bursts could theoretically be generated by a sufficiently advanced civilization. Their analysis suggested that if the FRB energy were collimated focused into a beam, the required transmitter could be powered by an array of solar collectors. They described this as a possible means of accelerating a light-sail spacecraft to relativistic speeds, an application of directed energy propulsion that physicists have discussed for decades as a conceivable form of interstellar travel. The paper was explicitly speculative. Loeb and Lingam were not claiming that FRBs are alien transmissions. They were calculating whether the physics allowed for it, whether such an energy source was within the realm of physical possibility for a sufficiently advanced civilization. The answer was yes. Avi Loeb went on to become one of the most prominent and controversial scientists, willing to take seriously the possibility of non-human technology in our cosmic neighborhood. In 2017, an object passed through our solar system on a hyperbolic trajectory, meaning it came from interstellar space and was just visiting, not gravitationally bound to the sun. It was designated 1I 2017 U1, more commonly known as Oumuamua, the Hawaiian word for a scout or messenger. It was the first confirmed interstellar object ever detected passing through our solar system, and its discovery was, on its own, a landmark event. Proof that objects from other stellar systems do travel through our neighborhood. Oumuamua was strange in ways that went well beyond its origin. Its shape, inferred from the way its brightness changed as it rotated, appeared to be highly elongated, cigar-shaped, or possibly flat, like a thin disk or pancake, in ways that do not match the shapes of typical comets or asteroids. As it left the solar system, it accelerated in a way that could not be explained by gravity alone. Not dramatically, but measurably, and the acceleration did not match with the combined gravitational effects of all the solar system's bodies would predict. Comets often show non-gravitational acceleration because they outgas volatile materials heated by the sun, and the jet of escaping gas acts like a weak rocket. But Oumuamua showed no evidence of how it had no visible coma, no detectable gas or dust around. It was completely dark in infrared observations, which should have detected thermal emission from outgassing, even if the gas was not visible optically. Yet it accelerated. Astronomers proposed various explanations. One suggestion was that it was a hydrogen iceberg, a clump of frozen molecular hydrogen that would outgas since hydrogen is transparent to the wavelengths used to search for it. Another was that it was a fragment of a
disrupted planet or moon with an unusual composition. Another proposed it was a nitrogen shard, broken off the surface of a Pluto-like world around another star. None of these explanations has been confirmed, and some have been disputed on physical grounds. Hydrogen icebergs would not survive intact during the journey from another stellar system. For instance, because cosmic radiation would have destroyed them long before they arrived. Loeb argued, and continues to argue, that the most straightforward explanation consistent with all the observed properties is that Oumuamua was a thin, light-propelled sail, perhaps a piece of technological debris from another civilization, drifting through interstellar space. The radiation pressure from sunlight could explain the anomalous acceleration if the object was sufficiently thin relative to its surface area, a shape that does not naturally form through geological processes, but that is a logical design for a light-sail spacecraft. His position is not the consensus view among astronomers. It is probably not even the majority view. But Loeb is not a crank or an outsider. He is a tenured professor at Harvard, the former chair of Harvard's Department of Astronomy, and a recipient of numerous scientific honors. His willingness to take the hypothesis seriously, and to say so publicly and at length in a book directed at general readers, forced the scientific community to engage with it rather than dismiss it. The deeper methodological point Loeb makes is worth dwelling on. Science requires that we consider all hypotheses that fit the data and eliminate them through evidence, not through the social discomfort that some hypotheses create. The extraterrestrial hypothesis for Oumuamua was consistent with the observed data. Ruling it out rigorously required positive evidence against it, evidence that, in some respects, has not fully materialized. Loeb's critics argue that the burden of proof lies with the extraordinary claim. His response is that in science, the burden of evidence lies with any claim, including the claim that something is definitely not artificial. To dismiss a hypothesis without evidence for its dismissal is not good science. It is the application of cultural prejudice in the name of rigor. We have established that strange signals and strange objects reach us from space and pass through our solar system. Now let us consider a smaller and more troubling question. What is happening in our own cosmic backyard? The moon has been the subject of human observation for tens of thousands of years, but it has only been the subject of close scientific examination since the 1960s. The Apollo missions between 1969 and 1972 put 12 human beings on its surface and brought back over 800 pounds of lunar samples that have been studied continuously for more than half a century. We know a great deal about the moon's composition, its geology, its history, its magnetic remnants, and its seismic activity. But the moon has also been the source of persistent anomalies that have never been entirely resolved, and the testimony of the people who have been closest to it sometimes takes unexpected turns. NASA's own archives contain photographs that have puzzled researchers since they were taken. Many of these anomalies have perfectly mundane explanations: unusual rock formations, camera artifacts, the play of light and shadow on an airless world that generates extreme contrasts unavailable on Earth. Human beings are pattern recognition machines. We see faces in clouds and figures in rock, and the lunar surface provides ample material for such projections. This cognitive tendency, called pareidolia, is well documented and accounts for the vast majority of reported anomalous features in planetary photography. But not every anomaly is so easily dismissed. In 1953, John J. O'Neill, a science editor for the New York Herald Tribune and an experienced amateur astronomer, observed through a telescope what appeared to be a bridge-like structure on the edge of the Mare Crisium. He published his observation, and it was subsequently observed and confirmed by H.P. Wilkins, director of the British Astronomical Association's lunar section, who described the structure as spanning approximately 12 miles. These were reputable observers with professional reputations to protect. Subsequent photographs of the region showed unusual formations in the same area, though the debate over their nature has never been resolved to universal satisfaction. The Shard, photographed by Lunar Orbiter 3 in 1967, is another case that has generated persistent discussion among researchers. The image appears to show a vertical, tower-like protrusion from the lunar surface approximately 1.5 miles high, with a geometry that some researchers have found difficult to reconcile with known natural processes on an airless, geologically inactive world. NASA scientists who analyzed the image in its time attributed it to a camera anomaly or photo development artifact. Others have argued that the structure's apparent geometry warrants closer examination. It is critical to approach these claims with rigor and appropriate skepticism. The moon's surface has been shaped by 4 billion years of meteorite impacts, ancient volcanic activity, and thermal cycling. The range of formations that can result from these processes is enormous, and human pattern recognition reliably finds order in randomness. Scientists who study planetary surfaces professionally have seen thousands of cases where an apparently significant formation turned out to be entirely natural. The default assumption must always be that natural processes are responsible, and extraordinary evidence is required to overturn it. What is harder to explain away is the experience of Edgar Mitchell, Apollo 14 astronaut, and the sixth human being to walk on the moon. Mitchell was a trained scientist. He earned a doctorate in aeronautics and astronautics from MIT, and a career naval officer and test pilot. After his return from the moon, he reported experiencing a profound alteration of consciousness during the return journey to Earth, a sense of deep interconnectedness with the universe that he described as being outside the frameworks of conventional scientific understanding. He spent the rest of his life investigating the edges of human knowledge, including the question of extraterrestrial contact. He stated publicly on multiple occasions, including in an interview with a radio broadcaster in 2008, that he believed intelligences from other worlds had been visiting Earth, that this was known to certain elements of government, and that the secrecy around it had been maintained for decades. Mitchell died in 2016. He never retracted these statements. Buzz Aldrin, the second man to walk on the moon, reported that during the Apollo 11 mission, he and his crewmates observed something during their transit to the moon, a phenomenon they discussed among themselves. He has described it as an L-shaped object reflecting sunlight at a distance. NASA's explanation offered later was that it was most likely one of the 4 panels that had separated from the spacecraft's third stage. Aldrin has accepted this as a possible explanation, while noting that they could not confirm it at the time. He has been careful in his public statements about it, neither sensationalizing nor dismissing what was an unexpected observation during one of the most historic journeys in human history. Mars provides a different and more richly documented set of anomalies. Decades of orbital photography and surface exploration have given us an extraordinarily detailed picture of the Martian surface. The most famous anomaly, the face on Mars, a formation in the Cydonia region photographed by Viking 1 in 1976 that appeared in the original low-resolution image to resemble a humanoid face, was definitively explained by higher-resolution photography from the Mars Global Surveyor in the 1990s. Later images clearly showed an irregular, eroded plateau rather than anything artificial. The face was an artifact of resolution and lighting, a cautionary tale about the limits of image interpretation. But the Cydonia region continues to attract scientific attention. Various researchers have proposed that several prominent formations in the region display geometric relationships that might be statistically unlikely to arise by chance, alignments to cardinal directions, or proportions that echo mathematical constants. The mainstream scientific community has not found sufficient evidence for artificial structures at Cydonia, but the debate illustrates a larger problem. Our tools for definitively distinguishing the natural from the potentially artificial on another world are still in their early stages of development. We know what natural processes on Mars produce because we have been studying the planet for decades. But our sample size is still limited, and our understanding of what is impossible on Mars is necessarily incomplete. The Mars methane mystery is more firmly grounded in reproducible data and is correspondingly harder to explain away. Multiple spacecraft, including the Curiosity rover and orbital instruments, have detected periodic spikes in methane concentration in the Martian atmosphere. On Earth, approximately 90% of atmospheric methane is produced by biological processes, the metabolic activity of microorganisms. On Mars, the source is unknown. Geological processes can produce methane without any biology involved. Certain reactions between water and iron-rich rock, called serpentinization, generate methane as a byproduct. But the observed spikes on Mars, localized, seasonal, variable in their timing and intensity, do not perfectly fit the expected
pattern from geological sources alone. The scientific community remains divided. The debate is open. We have now explored the scientific frameworks, the documented military encounters, the unexplained signals from deep space, and the photographic anomalies on nearby worlds. We come now to a more human dimension of this story. The accounts of the people who claim to have encountered something in the sky or elsewhere that does not belong to the world as we understand it. The classification of witness testimony as scientific evidence is fraught with difficulty. Memory is fallible and reconstructive. Perception is imperfect, especially under conditions of stress, darkness, or unfamiliarity. Human beings have been shown repeatedly to misidentify perfectly ordinary things. The planet Venus, lenticular clouds, military aircraft, atmospheric phenomena, under conditions where the ordinary becomes unrecognizable. And the cultural context of UAP sightings, shaped by 70 years of science fiction films, television programs, and popular mythology, creates an interpretive frame that can profoundly shape what people think they see and how they describe it. This is not a small problem. Any serious examination of witness testimony must begin with a frank acknowledgement of how unreliable human memory and perception can be. And yet, Somi, witnesses cannot be dismissed so easily. Some accounts come from individuals with exceptional observational training, with nothing to gain from their disclosure, and with a consistency of detail across years of testimony that is difficult to attribute to fabrication or confusion. Gordon Cooper was one of the original 7 astronauts selected for Project Mercury, the first American human spaceflight program. He was a career military officer, test pilot with thousands of flight hours in some of the most demanding aircraft ever built. In 1957, while serving as a captain at Edwards Air Force Base in California, Cooper and his crew filmed an anomalous disc-shaped object that landed silently on a dry lake bed, extended landing gear, then departed. Cooper filed a report and said the film was sent to Washington. He never saw it again and was told to keep the matter classified. Years later, he spoke publicly about the incident and stated his belief that intelligences from other worlds were visiting Earth. He maintained this position until his death in 2004. His record of service and his precise, detailed accounts of what he had witnessed make him one of the most credible witnesses in the history of this subject. Story Musgrove flew on 6 space shuttle missions, more than any other NASA astronaut, including the famous mission that repaired the Hubble Space Telescope. He holds advanced degrees in mathematics, computer science, chemistry, medicine, physiology, and literature, a list of academic credentials that is itself almost without parallel. He is, by any reasonable measure, one of the most intellectually formidable individuals ever to travel in space. Musgrove has stated in various interviews that during his time in space, he observed objects that he could not identify, and that did not behave like satellites, debris, or any other catalogued space object. He has spoken carefully and precisely about what he observed, declining to offer interpretations he cannot support with certainty, but making clear that what he saw was real, was unexpected, and was not explained by mission control or subsequent analysis. Leroy Gia, a former NASA astronaut and commander of the International Space Station, reported seeing lights moving in formation below the ISS during a spacewalk in 2005. He has described the sighting as unusual and genuinely unexplained. While expressing appropriate caution about drawing conclusions, he is representative of a broader pattern among astronauts who have spoken publicly about unusual observations. Careful, methodical thinkers who have seen things they cannot explain and are unwilling to either dismiss them or dramatize them occupy a peculiar position, trained to be precise and to question their own perceptions. They are also among the most reliable witnesses to unusual phenomena, simply because they observe the sky more carefully and more extensively than almost any other profession. The declassified documents of various government agencies paint a consistent picture of institutional awareness of UAP phenomena, combined with institutional reluctance to engage. Publicly, the Freedom of Information Act has produced thousands of pages of FBI, CIA, NSA, and military documents related to UFO sightings, investigations, and communications going back to the 1940s. These documents confirm, at minimum, that government agencies took the phenomenon seriously enough to investigate it systematically and to classify the results. They do not confirm extraterrestrial origin, but they do confirm that the dismissal of the topic as fringe or irrational was never the private position of government investigators. Even when it was their public one, the gap between what governments said publicly and what they were doing in classified programs is now, thanks to decades of declassification efforts, clearly documented. David Grush, a former Air Force intelligence officer and National Geospatial Agency official who had worked on UAP-related investigations for the government, testified before Congress in July 2023 in what became one of the most significant and debated public hearings on the subject in history. Grush stated under oath that the U.S. government has, for decades, been in possession of non-human craft and biological material of non-human origin, and that a secret program to analyze and reverse engineer this material has been operating outside normal congressional oversight, funded through mechanisms designed to conceal its existence. He stated that he had spoken with numerous credentialed individuals who had direct, first-hand knowledge of this program, and that he had reported their accounts through official whistleblower protection channels before going public with his testimony. He named no locations and provided no physical evidence during the open session, stating that doing so would require a classified setting with appropriate security clearances present. The Department of Defense issued a statement saying it had not been able to corroborate his claims, but notably did not call him a liar or threaten prosecution for unauthorized disclosure, both of which would have been expected responses if his claims were entirely fabricated. The congressional committee members who heard his testimony described it as credible enough to warrant serious further investigation. It is important to note what Grush's testimony is and what it is not. It is the sworn testimony of a credentialed intelligence professional with a verified background in UAP investigation, delivered before the United States Congress under penalty of perjury. It is not independently verified. It relies substantially on accounts received from others he has not named publicly. It constitutes, in the framework of legal testimony, what courts call corroborating witness accounts, not proof, but evidence that a claim has been made by people with apparent access to relevant information. It is not nothing. The cumulative picture of these witnesses present, military pilots, NASA, astronauts, government intelligence officers, career civil servants in multiple countries, is of a phenomenon that is real, persistent, documented in classified settings that the public has never seen, and stubbornly resistant to conventional explanation. None of these individuals has produced definitive physical proof, but their convergence on similar accounts across decades and independent of each other represents something that science is still learning how to process within its existing frameworks. Now we turn from what has been seen to what has been systematically searched for the organized scientific effort to detect signs of life beyond Earth. The search for extraterrestrial intelligence has evolved from a fringe scientific curiosity into a recognized scientific field with serious institutional backing and an increasingly rigorous methodology. The SETI Institute, founded in 1984 in Mountain View, California, employs dozens of scientists across disciplines from astronomy to astrobiology to anthropology. Its primary tool is radio astronomy, listening to the universe at carefully selected frequencies for signals that exhibit properties inconsistent with natural origins. What does an artificial signal look like? Natural radio sources tend to produce broadband emissions, energy spread across many frequencies simultaneously. A pulsar's radio beam sweeps across the sky like a lighthouse, producing regular pulses. But the pulses themselves are broadband, an artificial beacon designed for efficient communication. By contrast, would likely concentrate its energy into a very narrow frequency band, simply because that is the most efficient way to transmit information across cosmic distances. It would likely be coherent, maintaining regular phase relationships across its wavelengths. It might carry embedded information in the form of mathematical patterns, prime number sequences, or other structures that could not arise from known natural processes. These are the signatures SETI searches for, and they are specific enough that confusing them with natural sources should be difficult. If a signal is genuinely artificial and sufficiently powerful, the Allen Telescope Array in Hat Creek, California, built specifically for SETI research and named after Microsoft co-founder Paul Allen, became operational in 2007. It consists of 42 antenna dishes and can scan millions of radio channels simultaneously. More recently, the Breakthrough Listen initiative, funded with a commitment of $100 million over 10 years by Russian-Israeli Bill Yuri Milner, has brought the largest dedicated budget in SETI history to bear on the problem. Breakthrough Listen uses the Green Bank Telescope in West Virginia, the Parkes Radio Telescope in Australia, and the Meerkat Array in South Africa, as well as the Lick Observatory Optical Telescope, to conduct the most comprehensive search for technosignatures ever undertaken. It has already scanned millions of stars and hundreds of nearby galaxies. So far, it has found nothing definitively artificial, but it has barely scratched the surface of the parameter space it intends to cover. Technosignatures is a broader term than radio signals, and it has become the preferred language of the field in recent years. It encompasses any detectable sign of technology, not just intentional broadcasts, but any unintentional emission that might propagate across interstellar space. Earth has been broadcasting its presence unintentionally since the early 20th century. Our radio transmissions, AM and FM broadcasts, television signals, military radar, form an expanding sphere of electromagnetic radiation that now extends roughly 115 light-years from Earth. Any civilization within that sphere, with sufficiently sensitive receivers, could, in principle, detect these leakage signals. Similarly, a civilization broadcasting as it goes about its technological business, without any intent to communicate, might be detectable to us if it is sufficiently advanced and sufficiently close. The Dyson sphere, a theoretical megastructure proposed by physicist Freeman Dyson in 1960, has attracted increasing scientific attention as a potential technosignature. If a civilization wanted to harness the full energy output of its star, it might construct a shell or a swarm of energy-collecting structures around that star. Such a structure would dramatically alter the star's observable spectrum, reducing its visible light output while increasing its infrared emission, as the collectors would irradiate absorbed energy as heat. Searches for stars with anomalous infrared excess have been conducted with satellite data from the WISE telescope and others. Several candidates have been proposed, none confirmed as artificial, but the searches continue, and the sensitivity of available data is increasing. A star called KIC 8,462,852, more popularly known as Tabby's star, after the astronomer Tabitha Boyagian, who analyzed its unusual behavior, attracted worldwide attention in 2015, when researchers reported that it dimmed in irregular, dramatic, and unpredictable ways, unlike any natural stellar phenomena previously observed. At its most extreme, the star dimmed by more than 20%, far too much for even a gas giant planet, which would block less than 2% of its star's light. The dimming pattern was neither periodic nor symmetric. It came in complex clusters, with some dips lasting days and others spanning weeks. SETI researchers pointed the Allen Telescope Array at it. Astronomers around the world scrambled to observe it in real time. For a period, the hypothesis of an alien megastructure was taken seriously in peer-reviewed literature, not as the leading explanation, but as one that had not yet been ruled out by the available data. Subsequent investigation pointed toward clouds of dust and gas, possibly the shattered remnants of comets or broken-up planetesimals, as the source of the irregular obscuration. The color dependence of the dimming, with infrared light less affected than visible light, was consistent with fine dust rather than a solid structure. Most astronomers now accept some version of the natural dust cloud explanation, but the episode was significant for what it revealed about the current state of the scientific conversation. When genuine anomalies appear in astronomical data, the hypothesis of technological origin is now considered fair game for serious analysis, even if it almost never survives extended scrutiny. The James Webb Space Telescope, launched in December 2021, after decades of development and numerous delays, represents the most powerful tool humanity has ever deployed for studying the universe. Its primary mirror, 6.5 meters across and assembled from 8 hexagonal gold-plated beryllium segments that fold for launch and deploy in space, collects light with sensitivity far beyond any previous observatory. Its instruments operate primarily in the infrared, revealing the thermal signatures of objects too cool or too distant to study effectively in visible light, including the glowing embers of distant galaxies at the edge of the observable universe, the warmth of exoplanet atmospheres, and the chemical fingerprints of molecules in space. Critically, for the search for life, Webb can analyze the atmospheric compositions of exoplanets by observing them as they transit their stars, a technique called transmission spectroscopy. As a planet passes in front of its star, some of the starlight filters through the outer edges of the planet's atmosphere. Before reaching us, different molecules in that atmosphere absorb light at different wavelengths, leaving chemical fingerprints in the spectrum that Webb's spectrographs can read. The telescope can detect the presence of carbon dioxide, methane, water, vapor, oxygen, ozone, sulfur dioxide, and other molecules, including, in principle, those that could serve as oxygen in the atmosphere of an Earth-like planet would be a powerful indicator of biological activity, because oxygen is highly reactive and will combine with other elements on geological times. Maintaining it in high concentrations requires a continuous biological source, as plants and photosynthetic bacteria maintain it on Earth. Early results from Webb have already included the first detection of carbon dioxide in the atmosphere of an exoplanet WASP-39b, a hot gas giant 700 light-years from Earth. More importantly for the search for life, Webb has begun systematic study of the TRAPPIST-1 planetary system. Initial observations of TRAPPIST-1b, the innermost planet, suggested it may lack a substantial atmosphere. Bad news for that specific world, but providing critical data about what conditions planets in this system actually face. Studies of the other planets, including the 3 in the habitable zone, are ongoing and will occupy Webb for many years. Each observation adds to an emerging picture of what these worlds are actually like, rather than what we might hope or fear them to be. The Mars Sample Return Campaign represents perhaps the most direct near-term test of whether life ever arose on another world in our solar system. The Perseverance rover, which landed in February 2021 in the ancient river delta of Jezero Crater, has been systematically collecting rock cores from some of the most geologically promising sites on the Martian surface. The samples are sealed in titanium tubes and cached on the surface, waiting for a future mission to collect them and bring them to Earth in terrestrial laboratories with the full power of modern analytical chemistry available. Scientists will be able to search for chemical and morphological evidence of ancient microbial life at a level of sensitivity orders of magnitude beyond what any rover instrument can achieve. Jezero Crater was selected because it was once the site of a lake and river delta, exactly the kind of depositional environment where microbial life would have had the best chance of surviving on ancient Mars, and where biosignatures would be most likely to be preserved in the rock record. On Earth, ancient microbial life is preserved in sedimentary formations called stromatolites that can be billions of years old. Similar structures, if they exist at Jezero, would be within reach of the sample return campaign. The scientific community is cautiously optimistic. The pessimists note that even if Mars once had life, the harsh conditions of the last 3 billion years may have destroyed all evidence. The optimists note that Earth's oldest biosignatures have survived comparable timescales in the right geological context. We have covered enormous ground, from the mathematical statistics of habitable worlds to the testimony of astronauts, from the radio silence of Wa to the chemical plumes of Enceladus, from classified Pentagon videos to the spectral analysis of distant atmospheres. We come now to the theoretical dimension. What does it all mean, and where might it lead? The concept of panspermia, the idea that life can travel between worlds on meteorites and other debris, potentially spreading through planetary systems and beyond, has moved from philosophical speculation to serious scientific hypothesis over the past several decades. We know that rocks are Martian organic chemistry could in principle have delivered biological material from Mars to Earth, or from Earth to Mars. We also know that some microorganisms can survive the conditions of space. Trapped the extreme radiation of the interplanetary medium, the vacuum of space, the temperature extremes of deep cold for remarkably long periods, particularly when embedded within a rocky matrix that provides shielding from the most damaging radiation. Experiments aboard the International Space Station and on previous space missions have tested the resilience of organisms in space, and some have shown that spores and dried cells can survive for years under exposure to space conditions when protected by a thin layer of rock or mineral. Lithopanspermia, the transfer of life within rocks, has been modeled, and the results suggest that transfer between Mars and Earth, in both directions, is physically plausible over the history of the solar system. If life arose on Mars before the impact rate declined and conditions became harsh, some of it might have been transferred to early Earth on meteorites. If life arose on early Earth during the same period of intense bombardment, some of it might have traveled in the opposite direction. The two biospheres might be related. Life on Earth might have Martian ancestors. Life on Mars, if it existed, might have been our cousin. The implication of successful panspermia, if it occurred, is that finding microbial life on Mars would not automatically prove that life arose independently there. It might prove only that the same life arose in one place and was transported. This would not diminish the significance of the discovery. A single independently documented example of life arising anywhere in the universe would still be the most important scientific finding in history. But it would mean that the question of how many times life originated in the universe remains open even after Martian life is confirmed. The more radical extension of this idea, direct to panspermia, was proposed in the early 1970s by Francis Crick, co-discoverer of the structure of DNA, and biochemist Leslie Orgel. They suggested, with acknowledged speculation, that life on Earth might have been seeded deliberately by an advanced extraterrestrial civilization that existed billions of years before our own. Their motivation was partly the remarkable speed at which life appeared on Earth, within a few 100 million years of the planet's formation, and partly what they saw as a deep universality in the biochemistry of life, particularly in the genetic code, which they argued might reflect an artificial design rather than the product of natural selection alone. The hypothesis is essentially untestable with current tools, and it has not been widely adopted, but it was proposed seriously by serious scientists. And it remains a reminder that the history of life on Earth might be entangled with a history of intelligence in ways we cannot yet detect.